And go. Hello, in this episode, we'll review Python. Okay, so some of you may know Python, some of you may have not seen. But for TensorFlow, basically, you just have to understand some basic Python features. I am not going to delve too deep into the object-oriented programming and many of the fancier features. Maybe in the future I may, but not for now. And for many of the neural network applications, oftentimes you can get by without knowing them. So this is just the basic feature for Python. And if you have used any scientific calculator like TI-84, or have done a little bit of calculation in Excel, Python is pretty much like that, except Python makes it a lot more convenient and easy to use than those languages or calculator. And the first thing I want to mention is that there's a Python ecosystem that when we installed, we mentioned briefly that the Python is a general purpose interpreted programming language, to be technical. Sometimes people are picky on this, which means that as the line is typed in, the computer tries to translate it. That's what interpreter does. There are some other programming languages like C where they do compiling. So you actually have to type the whole code and then translate it in a batch, and then the computer will understand the whole sum program. Okay? But anyway, so that's a technical thing. In essence, Python is a language that you can translate the text so that the computer can understand and do some chores for you. Okay? And it's very easy to learn because the language was created with the readability in mind. It's also very popular. It's oftentimes one of the top 10 programming languages in the Stack Overflow, which is a common computer scientist or geek kind of a web group. All right. So it's a very popular language among programmers. It's also very dynamic for quick prototyping, meaning that you can just quickly type things and see how it works, whether you like it or not, and you can quickly change it. It makes it very easy to do so. Right. And there are some packages that for deep learning, especially machine learning and deep learning, is useful. SciPy, NumPy, Matplotlib for plotting, Pandas for Excel-like features, and scikit-learn that has a whole bunch of regression and other algorithms coded already for you. So, and for the Python language, I'll basically summarize some key features of how to assign variables. And a flow control. Flow control means like if something, then do this. Or for how long, do stuff like this. You know? It's iteration, what we call, and it's conditional statements, what we call. Okay? And then the data structures, where to put the data. Other than the simple variables, Python has tuple, list, and dictionary, which we'll go through. And their functions, it's like if you have used Excel, you can sometimes batch some of the commands together, call it macro, isn't it? Like Excel macro function is something like this. Under one name, you just call that magic word and it will do a whole bunch of operations for you. And then there's a Numpy, which is an array, and Matplotlib and Pandas, and loading external data. So we'll go over these one by one. Okay. So first we'll have to go to invoke Google Colab. I did prepare a code just to speed things up the discussion. So let me just upload it. So in my Google Drive, I'll go to Google Colab, and then I click the new and file upload. And here's my Python review. So a Python crash course. Okay, here it is, Python crash course. So, so you can see that if you remember the Jupyter, how to use it. So the first, second, and third cells are all kind of the text markdown cells, isn't it? These are text. These are not what the Python programmer will understand. The fourth cell now happens to have a couple of comments that the computer can understand. So the assignment is, if you think about using a calculator, usually you just put the number directly, it's an 8, and then you put an operator like plus, and then another number, let's say 2. So 8 plus 2, and then you put the enter button and it will give you the answer 10, isn't it? If you do this, then if the number changes to 7, and then what's 7 plus 2, you kind of have to retype the whole thing again. That's very annoying, isn't it? So what computer program does for you is that it lets you store some numbers for you, right? In a memory key, isn't it, in a calculator. Instead of doing this, in computer language, we have something called variable, and we just store data in there, and the data can be more frequently a number, but it doesn't have to be here. I just happen to call whatever I want to call. Usually alphabet, using alphabet would be a good idea, but you can mix it with numbers. But here I nicknamed something called data. So this is the name of my memory, and we did hold a special thing called hello world. Okay, so I just happen to have storing a non-numeric information, which is the string hello world. These are 11 characters, so I have it. What can I do? You can imagine what this will do. The next line, print, and then the data. And I have in a square bracket 6. What does that mean? It means that in the data, so data contains hello world, these 11 characters, isn't it? The sixth one, give me the sixth one. Actually, it is not quite correct. Strangely, in Python, the indexing starts, the counting starts from 0. So the 0th element in data is H. Element 1 is E, 3 is L, 4 is L, 5 is O. So it's the 7th element that's data 6 actually means the 7th element. So the 7th element is actually W, okay? Print me the 7th element in the data, which is W. That's what data 6 means. So it's the counting starts from 0, just to keep in mind. The next line also gives you, and you don't have to memorize all of these comments that the Python provided, but LEN, you can imagine, well, it gives the length of the data. How many characters does it have? 11, isn't it? Yeah. And then print the data itself. It will just print what's there, hello world. So can I execute it? Okay, I already did that. But if I exit and then run it, it will run it. Okay, hello world. It's 7th element was W. The length is 11 and hello world. Similarly, I can name a different variable now, value, and I put 2022.1. And what's the original value? So in the, it's a string, and then I print the value. Okay. And then I can actually, the variable can change. That's why it's called variable. I can change my mind and now put in the value, dump a different number, let's say 10, and then let me print that. Okay, so if I actually execute it, original value is 2022.1, and then after it's being replaced, it becomes 10. So this is how variables are being used. And the nice thing, if you don't know any programming language, you won't appreciate how easy it is. For other more fancier languages like C++, you may heard, you actually have to tell the computer first whether you are going to store in a variable a number or a string or a character, and you have to write so-called a declaration, and then you can use it. And if you declare it as a string and then put a number in there, it will give an error. The computer will complain about it. In Python, no need for it. Just name whatever you want to name it and put an equal sign. It's an assignment sign. Then put whatever you want to put in there. It will go in there. Okay. And if you print them, it will just print what's in there. Okay. Number and strings are not the only things you can store. You can store Boolean, true, false. It's in blue because true is not a character. It actually means something like a logic. Okay? So the computer internally recognizes as a true, false itself. Also, if you're lazy, in the lazy mode, and you don't want to assign x equal 1, y equal 2, z equal 3, you can just put in a comma in one line in one shot, x comma y comma z equal 1 comma 2 comma 3, which will put in x 1, y 2, z 3, right? So you can print it and look at it. As well as there's something called no value, none. Again, it's in blue because it's not a character. It actually means something for the computer. It's null value. Okay. So that is about assignment. You can, assignment is fairly intuitive. It's like the memory in your TI-84 calculator. You assign and put some number in there, except Python is more nicer. So other than numbers, it will let you allow to put some other stuff in there too. The flow control is usually what makes a program useful. So sometimes you want to just run some command and do the computer do something if some conditions are met. It's called if, else, and then something kind of simple. So if, else, if, else. So if here's a value 299 being stored. Okay? If the value is larger than or equal to 99, then print the following. Okay, so here's, you don't only have to ask them to do one comment. You can actually print multiple comments and have in multiple things. I'm just showing you one comment here. So I'm printing that is too fast. Okay, so in this case, it's probably true, it will execute it. But if the first one is not true, then you can have if value is larger than 199 or equal, then let me print that is fast. And if even that is not met, then else, then print this. But you have to be very careful is that after the condition, there's a colon here, isn't it? In Python, colon is very important in the sense that it signifies that whatever comes in the next line and below will belong to this upper command, that's right above, meaning that if value larger than 299, then do this. How do I know when it stops? The indentation is very important. Whatever is with the same tab will be recognized as a block that belongs to this if. So elif and then value larger than 199 colon and the line below and forever with the same tab belongs to this elif and so forth. So here value is 299. So I'm pretty sure it will just print the very first line, which is that is too fast. But if I change this to 199, it will print the second one. That is fast, isn't it? And if I change it to 99, then nothing is met. And the last line, the else statement will be that is safe. Isn't it? That is safe. Well, that is a bit off one. So this, that is safe. Okay. All right. Other than this conditional, so if conditions are met, then the conditions are met. You can also have him repeatedly do some mundane stuff. So here for loop is for, and then you can name any variable you want. I usually use II, and then in range 5. Range is a command that generates integer from 0 to 5 numbers starting with 0. So 0, 1, 2, 3, 4. So, and what the for command will do is that every time it meets an II, it starts with II0, and then it will run and execute the following line. Here I'm just using a print line just to show you that it did, II changed, but you can do addition and many other stuff. So it will repeat it 5 times basically. So this is a command that when your boss tells you, oh, repeat this 1,000,000 times, that will eat up all your lunch time. That will be a pity if you were to do it just one by one. Instead of doing this, just hook it up in a for loop, and then you can just go for lunch and come back after a coffee and show your boss, yeah, here are the 1,000,000 numbers that I put. Another very similar thing is a while loop. So here I'm using my index JJ just for the sake of I can do it. So JJ equals 0. So I'm putting 0 in a JJ. And a while is used when I don't know how many times I want to repeat, but I'm going to repeat until I'm happy, meaning the following conditions are met. JJ less than 5. And then there is a colon. Okay? Colon means, again, there's a block below. And with the same tab, all belongs to the same while command. So while JJ is less than 5, print JJ, JJ plus equal 1. What does that mean? It means that JJ increase it by 1 and put it back into the JJ. This is actually, so if I run it, you can imagine it will print 0, 1, 2, 3, 4, because the JJ is 0 printed, and then increase it by 1, and then go back and print it, and increase by 1 and go back and print it until JJ is less than 5, which is 4 is the maximum number. But if I were to just do it like JJ equal JJ plus 1, this will do the same thing. All right. So just so you know. Okay. So now, so here the flow control are probably central to why people use programming language. Any Fortran, C++, C, Pascal, whatever language you have seen, you pretty much like to have these features, conditional and repetition iterations, isn't it? Another thing that's very useful in programming language, unlike calculator, is that they will allow to store multiple numbers under the same name. It's usually called an array, isn't it? There are different kinds of array in Python. The first thing is here, a equal, let's say in a parenthesis, 10, 20, and 33. Print it, it's 10, 20, and 33. If I try to change that a, let's say 0, 1, what it will do, it will give me an error. This is called tuple. In a parenthesis, if you give series of numbers and dump it to a variable, it will recognize this as a tuple, which means you cannot change the number afterwards. Why would you create something that you cannot change? But sometimes you want to create an important information that later in the program you never ever want to change. For example, customers' passwords, or some system variable that actually means to the computer, and if you change it, you screw up the computer setting to blow it up. In that case, people tend to put it in a tuple to be safe, right? Well, what you can see is that it belongs to probably for a human being, it meant something. So under the A, you put this series of numbers, like if it were GPA, for example, the variable name, then that contains the GPA of multiple students in a class, for example, like this. If you want to change it in the middle of the road, down the road, then you can use a list. It's in a square bracket and you put series of numbers here, like my list equals square bracket 100, 200, 300. And then the my list 0 is the first one, which is 100. And the length of my list is 3, isn't it? Well, actually, you can add under my list later on, like append and then put whatever you want to put in. Here I put 400. So, and then check the length of it. And then you can use a for loop to go through the my list. If you use a for loop, and like in this case, like in my list, that then each time the for loop hits the new round iteration, it will go to the next element of the my list and repeat. So you can see it will do this kind of things. There's another special thing, very neat for Python uniquely, which is in a curly bracket. It's called dictionary, and it is like an English dictionary. Usually a list, you can go to, let's say if I want to go 100, I have to call my list 0. If I want to go to the second element, I have to go my list 1. Okay? So it's indexed by an integer starting with 0. So my list 0, my list 1, my list 2, my list 3, something like that. Sometimes you want to index or find things by other things, let's say alphabet, like a dictionary, isn't it? What's in a dictionary in letter I? And then iterate, irritate, and something. So you go by the alphabet, isn't it? It's not like you go to the dictionary, the second element of the alphabet, which is B, something like this, isn't it? So in that case, what you do is that we can index it by the index. We can put it in a single quotation mark and put whatever we want to index by, and then store a value for it, and it's separated by a colon. And you can have many, many dictionary items like this. So my dictionary X is 10, Y is 20, Z is 30. Now later when you want to call it, my dictionary X will give you a 10, isn't it? Something like this. We call this X, Y, Z keys and the value 10, 20, 30 as values, and you can call them also. So here's a print statement that shows you basically. Okay, so that is how to store data. So can store meaningful connected information in a single name, which a tuple, list, or dictionary. The next thing, I think if you have ever used an Excel, are the macros, isn't it? Excel have a macro. So if you have a copy, paste, align, delete, add, sum, whatever, and you want to do them over and over again, rather than calling this command individually over and over again, which will be very tedious for you, you can just package them together and give it a nickname and just call that nickname, and it will do run shebang of commands for you. So here, for example, and it's called function. how you do it is that def and then have your name, your MySum, and then in a parenthesis, give all the ingredients what you need, meaning the input variables you need for that function to work. And then put in a colon, and after a tab, we do series of operations. For example, here I'm adding two numbers, x and y are given, and add the x and y and put it in MySum, x multiplied by y in the next line, and I'm keeping it in my product. And don't forget to return, so it's in purple here, isn't it? Which means that it actually belongs a Python language. Return, and then what I computed, MySum and my product, I'm passing it back. So whenever you call MySum and give two numbers, it will do this addition and multiplication and return that result. So for example, if I call MySum 1 and 3, and it will pass two numbers, the first one being 4 because it added the 1 and 3. And then the second number should be, yep, you guessed it, 3, isn't it? Multiply 1 and 3. Okay, so this is sort of the basics of Python language, so which people spend a whole semester sometimes for that. But in essence, those are the things that you need, right? Fairly simple. Now, the following is something unique for machine learning. So people already, the Google engineers programmed a lot of functions for you, so you don't have to. The first thing is Numpy. So how do you call those packages? You call them library, import. Import Numpy, okay? If you import Numpy, and then what it will do is that if you have a list, let's say my list in a square bracket 10, 20, 33, which is fine, except that if you have a million items of them and want to multiply them, it will take a while for you. You can try, I'm not going to. But you can convert it to a NumPy array, like NumPy.array, and then have the list name in here and pass it on to wherever you want to save it, my array. Then it will become a NumPy array. Okay. And it apparently, in appearance, it doesn't have much difference. But what is actually different is that the speed, when you actually multiply things with NumPy array, it is a whole lot faster. Okay. And yeah, so here's how to show you how to access the array. It's almost the same as list. My array 0 is the first here. First row, and the last row is my array -1. Okay, and if you can index a specific row and column, like a 0 row and column 2, yeah, or if you can do slicing, what we call a colon comma 2 means that it picks up the whole column 0, 1, 2, the third column, isn't it? So you can just run this. You can also do element by element multiplication and addition. So you can do the plus sign to the addition and multiplication sign to the multiplication. It is not a vector dot product. It's an element by element multiplication or addition. Okay. All right, here we go. Another thing that's very useful is once you have something, you want to plot it. For example, here, Matplotlib, PyPlot is very frequently used, and there's a trick for using a library here. Import matplotlib.pyplot, and I'm having here purple as and plt. What does that mean is that matplotlib.pyplot is a very long name. I don't like it. So I'm going to nickname it as plt, and in the future, whenever I want to type matplotlib.pyplot, I'll just have to type plt and I'm done. Import NumPy. And suppose that there's an array, NumPy array 1, 2, 3, and I'm a list of 1, 2, 3, I'm converting to a NumPy array, my array here. If I want to plot, so plt, which is actually long spelling out, matplotlib.pyplot, instead of that. So I'm just typing plt.plot and my array, it will plot this line. And plt.x label, plt.y label, can do all that and it will plot this line, right? You can also do scatter plot, which is plt.scatter. You need an x variable and a y variable, of course, and scatter needs x and y. You can do it. All right, so this is how to plot. And if you Google and type Matplotlib, it will give you a garden variety of tutorials, examples, code, so you can name it. But these are the basic things that for the time being will get by. Panda is like an Excel for Python. So when you want to read in an Excel file or want to do column or row operations, typically Panda is your guy. So import Numpy and import Pandas. So typically it operates on Numpy array. So we create a Numpy array and have a list of array row names. And then we can create a series, Pandas series, my array, and index with the row name. It will create my series. And then if I call in just the first one, which is row name A, it will give me that 10 here, okay? There's even better thing, it's a spreadsheet, which is like a row and column. It's a data frame, isn't it? So if I have a my array, Numpy array, 1, 2, 3, 4, 5, 6. So it's a 2 rows, 3 columns kind of spreadsheet. So here I have a my array. So it's a Panda data frame command. Okay? And if I have a my array and give the index row names and the column names that I gave, it will create a spreadsheet for you and you can print them. And as you can imagine, if you just call that in a square bracket, you can pull out the row and column as you wish. Right? Finally, and I reviewed it when I'm using Google Colab. So if you're using Jupyter, you can just save it in and give the direct full path name in the file name. But for Google Colab, just as a reminder, if you have a Panda, and if you want to just upload a file in from a local library, then from Google Colab import files, the next line uploaded equal files.upload. If you just run that, it will allow you to choose files. You can go wherever you want. So it's episode 9 input data. It's being read, isn't it? You could have used Google Drive, and I referred to their previous episode on how to use Google Colab, and there you can see how to do it, upload file on Google Drive and then access the Google Drive file. Anyway, so import pandas at PD and then give the column names here. So how does actually that input data look like? Here's the EP9 input data from a local file. It has like 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, and how many rows? 718 rows. I can just create a read CSV. So this is basically the Google recognized that local file, but it's not in my Python program. So I have to store it in a variable. So PD, the Panda as PD, so nickname for Panda is PD for me. So PD.read CSV, give me the file name and then the column names, and then it's being read in. So this is how you load data, which probably will be useful time being. I mean, there are more fancier features in Pandas, but these are just for starters, giving some basics for you to get started. So just to summarize, we did assignment, flow control, like if something or for something, and then the data structures, functions, and some basic features on Numpy, Matplotlib, Panda, and loading external data. There are a lot more variety and rich features of each of these. And in Google, if you type each of these names, Numpy or Matplotlib, they will give you a very friendly instruction. Also, there are many YouTubes that instruct you, but I was just giving you for starter. Okay? So this is it was a quick summary of the Python language. Thank you.